So continuing with the topic of miscellaneous agents, today we are going to cover starting from hematinics. So starting with the topic. So starting with hematinics, so these are the agents which are responsible for blood cell formation, which basically increases the blood cell count, increases hemoglobin, erythrocytes, thus can be used in treatment of anemia. So main hematinics known are the ferrous ions, yes, then vitamin B12, folate ions, etc. So these are basically the pills or the tablets which are taken for anemia to increase hemoglobin levels. So the inorganic compounds which are used as an hematinics are ferrous sulfate, and another one will be ferrous gluconate. So starting with this one, it is iron vitriol, also known as green vitriol, with the molecular weight of 278. Its preparation is with H2SO4, that is sulfuric acid. What we get later is Fe2SO4 with H2 evolved. Then second is moist iron pyrite, that is FeS2 to air, gets oxidized to form ferrous sulfate. Third way of preparation is FeS2 with water, and what we get is FeSO4. So this is basically how ferrous sulfate is prepared. Then these are basically the properties of ferrous sulfate. So this is the greenish powder, also known as green vitriol. Like I said, it has astringent in taste. It is soluble in water and it is insoluble in alcohol. So on heating FeSO4, what we get is Fe2O3, okay, and SO2. It decolorizes with acidified KMNO4, that is potassium manganese, to potassium dichromate green. So these are the basic properties of FeSO4, ferrous sulfate. This is how it appears. Then starting with the assay. Assay is by principle of oxidation reduction reaction. So this is basically the equation and the reaction of how assay is performed, with using 0.1 normal KMNO4 in presence of dilute H2SO4, in which we get the RFeSO4 acid. We know the purity of the inorganic compound. Then FeSO4 uses are it is mainly used as hematinic because of presence of Fe ion in it. Then it is thus used in treatment of anemia. It is also used to dye fabrics and tanning clothes industry, and it has a disinfectant property. Then second inorganic compounds under hematinics is ferrous gluconate with molecular weight of 408.2.18. This is basically the formula of ferrous gluconate. The properties is like it is a fine yellowish grayish kind of powder with odor like a burnt sugar. It is light sensitive. Therefore, the work of assay will be done in the light sensitive environment. Then talking about its solubility properties, it is soluble in water but insoluble in alcohol. Then solubility can be increased by addition of citric acid. In preparation, ferrous carbonate when heated with gluconic acid, what we get is ferrous sulfate, and calcium gluconate with ferrous sulfate, what we get is ferrous sulfate. Then uses it's hematinics, much safer than ferrous sulfate, and can be used in anemia with lesser side effects. Okay, so this is the formulation of ferrous gluconate. Ferrous gluconate is used in the form of tablets or elixirs. So this was all about hematinics. Second is the next category is poison and antidote. So what is a poison? Poison is basically which produces ill health or a disease or causes death. That is something which is known as poison. So classifying poison, it can be divided into three categories, that is intentional, unintentional, and undetermined. Okay, so intentional are the ones which is kind of a suicide type of poison intake. Then unintentional is something like which happens on absorption of wrong compounds. or taking higher dose unintentionally of a compound or a drug. It's something unintentional. Undetermined is something which we don't know the cause of the illness or the death because of which the poison intake has happened. Then what is antidote? Antidote is something which neutralizes that poison, which nullifies that toxic effects. Okay, so so there are classification of antidote as well, that is physiological antidote, chemical and mechanical. Okay, so how does physiological antidote act? It is by opposite effect of that of poison. Chemical is the one which changes the nature of the poison, and the third, mechanical antidote, which prevents the absorption of poison further. Okay, so these are the type of classification for antidote. So sodium thiosulfate with molecular weight of 248.80. So let's look into this compound. So synonym, it can be sodium hyposulfite or antichlor. So it is basically the preparation is by boiling sodium sulfite with sulfur. Another way can be reacting NaOH with the sulfur. So talking with the properties, it's a crystalline powder, effervesces in dry air, soluble in water, insoluble in alcohol, then aqueous solution decomposes slowly. Then it's iodometric titration. One thing to note that sodium thiosulfate has iodometric titration. So this is some important, so these principles of all the compounds that we are discussing are something important to remember. Principle of assay. So for principle of assay in for this compound, that is sodium thiosulfate, is by iodometric titration. Okay, and its mechanism is for the cyanide poisoning. Okay, so this is basically an antidote for cyanide poisoning. Okay, then uses, it is for cyanide poisoning. It has an antifungal effect when used topically, effective antidote for several other metals and compounds or molecules. Then standard titrant in iodometric analysis. In textile industry, it is used in anti-chlor agent in bleaching process. So now activated charcoal. So activated charcoal, it is black, fine, odorless, tasteless powder free from gritty matter, insoluble in water and organic solvents, etc. So talking about activated charcoal, this you must have seen in many ads and advertisements that charcoal gives an absorption effect so that it just cleans out everything. So be it a mask, a facial mask, or be it some toothpaste, for example. So these are the basic uses which gives charcoal an absorptive property, which is having an absorptive property, activated charcoal. So let's look into the preparation point of view. So where does charcoal comes from? It comes from material like wood chips, sawdust, etc. Then some chemical reagents like zinc chloride, phosphate are mixed and then baked in higher temperatures, that is 500 to 700 degrees Celsius. Then purification is done, then drying is done, then sieving, crushing. What we get is activated charcoal. So this is basically the preparation. Then uses, it is the great use is an adsorbent. It is used as an adsorbent. It is also used in a burning fuel. So you must have seen this in big ships or something. They use this charcoal as their burning fuel. Okay, so it is also a constituent for gunpowder, etc. So next is sodium nitrite. So talking about sodium nitrite, it is some white crystalline mass of powder. Okay, it is soluble in water. Its solubility parameter, soluble in water, less soluble in alcohol. It is odorless in nature. So this is basically the preparation. So this was the part which was discarded. So let's look into it. So this is the first way to prepare NaNO2, that is by NaNO3, which liberates oxygen. What we get is NaNO2. Then with NaNO3 and lead, what we get is NaNO2 and PbO, lead oxide. So this is not something you should consider. These two reactions are something which are to be taken into consideration. So uses for cyanide poisoning, again, the nitrite ion shows vasodilation effects on blood vessels, okay, and used as anti-rust solution in rusting and surgical instrument. Then talking about astringents. Now that we have covered poison, antidote, hematinics, another last category under miscellaneous agents is astringents. So these are something which bring about protein precipitation reaction. Then the precipitated protein and the astringent forms a protective layer on the surface, due to which it it is able to reduce the cell permeability property, okay, because of which the transfer is stopped. This is basically the astringent effect which has been shown. So usually it is used for damaged skin. It basically reduce eczema, reduce exudation and inflammation. So the basic what you can say mechanism is here, that is astringents are able to reduce the cell permeability. Okay, so the examples we are going to look on is zinc sulfate and potassium alum. Then starting with zinc sulfate, it is odorless with astringent to metallic taste, efflorescence in air. Then it is soluble in water and insoluble in alcohol. So when zinc with H2SO4, what we get is zinc sulfate, and with ZNS, that is zinc sulfide, and oxygen, what we get is zinc sulfate. So this is method of preparation and properties of zinc sulfate. Then chemical properties. Solution acid to solution to phenol red, and not an acid to solution of methyl orange. What they are talking here is that the solution acid to solution of phenol red, which means phenol red, the solution acts as acidic in the solution of phenol red. In the solution of methyl orange, it is not an acid. Okay, when strongly ignited, it decomposes, then forms double salts with potassium and ammonium sulfate. The white crystalline of ZNS is formed when zinc sulfate reacts with hydrogen sulfide. Then it has emetic action. It is used as an astringent externally. It is used as for ophthalmic purpose, that is 0.25%. Then aqueous solution of zinc sulfate is employed for protein precipitation. Then another compound for astringent is potash alum. These are the crystals of potash alum, colorless, transparent, has a sweet astringent taste, and are anhydrous, and it loses water on heating, thus can become anhydrous compound. Then it is soluble in water and it is insoluble in alcohol. So this is method of preparation of potash alum. So it is basically potassium sulfate with aluminum sulfate. What we get is potash alum, the crystals of potash alum. Okay, then astringent, it is used as astringent, protein precipitation property, also known as astringent, preparation of toxoids. Then it is used as an antiseptic, and alum is used as an pharmaceutical aid. Okay, so the references are Chatwal. You can refer Chatwal. You can refer Roshan Block for inorganic chemistry. So thank you for your attention.